For conversions, we'll be using the conversion table that's available in the course, or you can use your formula sheet as well. We need to convert from feet to miles, and to do that, we use the conversion. And so we start with what we've been given, and using the factor label method of conversion, we can use our conversion factor, write down an identity ratio, and then use that to convert from feet to miles. So we can multiply everything on top and divide by everything at the bottom, and that gives us 5.5 miles. To convert from gallons to pint, since there is no one direct way of doing that conversion with our conversion table, we need to convert from gallons. We need to convert from gallons to quarts, and then from quarts to pint. 15 gallons, and then we do our conversion from gallons to quart, and then we can do our conversion from quart to pint. So what we have is multiplying everything on top, divide by everything at the bottom, which is just 1, and so that gives us 120 pints. We've been given an area in square inches, and we need to convert that into square feet. And since we are doing the conversion in square units, we need to do our conversion twice, so that this and this will take care of that. And feet times feet gives us square feet. And so we have 1064 over 144 square feet, which is 7.39 square feet. For dosage calculations, we've been given how much the person weighs in pounds, and so we need to convert that to kilograms to determine how many milligrams we need to give that adult per day. And so we start with the person's weight, which is given as 220 pounds. And then using our conversion table, we can convert to kilograms. Once we have our conversion to kilograms, we know the dosage limit is given as 10 milligrams per kilogram per day. And if we're given the drugs 2 doses per day, then we multiply everything on top, divided by everything at the bottom, and that gives us 499 milligrams per dose. We have 420 miles as the distance. If the car gets 24 miles per gallon, then we can write this as an identity ratio as 1 gallon over 24 miles, because we want to determine how many gallons of gas you end up using if you travel this distance. Once we know how much gallons, we can multiply that by our conversion factor, because we know for every gallon of gasoline that is burned, 19.8 pounds of CO2 is released. And so we can cancel out our units and then multiply and divide. For every kilowatt hour of energy used, 1.37 pounds of CO2 is emitted. So for a 100-watt fan, we need to determine how much kilowatt. And to do the conversion to kilowatt, we just divide by 1,000 watts. And it's used 8 hours per night. And so we have 8 hours in a day for 365 days in a year. And this is because we want to determine how much CO2 is produced in a year. And then we can multiply that by our conversion factor. So we see here that watt and watt cancels out, days and days cancel out, and so we have kilowatt hour per year. And so again, multiply everything on top, divide by everything at the bottom, and that gives us about 400.04 pounds of CO2. We've been given how much average pounds of garbage we have, and then its standard deviation. And so we can create this normal distribution table to determine what values are 1 standard deviation, 2 standard deviations, and 3 standard deviations away from the mean. And our average value here, which is mu, is 1700. So we have 1900 and then 1100. To calculate the z-score, we know z is given by x minus mu over sigma. So if x is given as 1300, then we can determine what our z value would be. That represents how far it deviates from the mean value. So you are -2 standard deviations away from the mean. And from our z-score table, we can determine what the probability is. And so we have about 2.28%. Remember that the z-score table gives us the probability to the left of the distribution. And so if we need to determine the probability to the right of the distribution, for example, if we want to determine that someone generates more, then we need to make sure that we subtract the decimal from 1 or the percentage from 100. And from our table, we know the probability is given by that. The probability that it generates more becomes 1 minus 0.9332. We can determine the z-score here as well. So this time around, we want to determine what percentile. Okay, probability, proportion, percentile, we're talking about the same thing. This that represents the 69th percentile. We have a table that represents the rating in stars and then the number of ratings. We want to determine the total, so that will be 959. We're told to determine the probability it receives a future rating of at least 4 stars, which means 4 or more. So we'll be looking at these. So we know probability is given by the number of ways an event can occur divided by the total number of outcomes. The total number of outcomes that we have is 959. And so the sum of these two numbers gives us 876 divided by the total, and that gives us 0.913, so about 91.3%. We have a table that represents the alpacas, male, female, white, mixed color. So first, let's determine what the total of all these are. So what is the probability that an alpaca chosen at random is of mixed color? What is the probability that an alpaca chosen at random will be white or female? But since there is this intersection where we have counted the white and female twice, we need to subtract that so that we don't end up counting it twice. What is the probability that an alpaca chosen at random will be white and female? If an alpaca is white, what is the probability that it is male? There is a condition here, and the condition is that the alpaca is white. So that changes our denominator. And so we have 23 over 51. That gives us 0.45, which is 45%. This table shows us information about doctors, lawyers, and engineers. The conditional probability, the condition becomes the denominator. The condition here is that the person is a woman. So the probability becomes, the condition here is the person is a doctor. The condition here is the person is a woman. For this, there is no condition, and so we need to be careful. The probability will be divided by the total. Since we have an accuracy rate of 90%, what that means is that 90% of the time the alpaca has the choking disease, 90% of the time the alpaca does not have the choking disease. Now we know that 4% of the alpacas have the choking disease, so the total number of alpacas is 1,000. So 4% of 1,000 will be 40. That leaves 960 that do not have the disease. With our accuracy rate, we can determine how many of these will test positive. And then we can determine those that will test negative by just subtracting. Similarly, we can determine those that will test negative, subtract from the total, and we have those that will test positive. So we have a total of 132, and then we have 864. You may want to double check to make sure your numbers add up to the total. Positives, false negatives are conditional probabilities for the most part in our discussion. If an alpaca tests positive, what is the probability it has the disease? If an alpaca tests positive, what is the probability it does not have the disease, and what is this test result called? If an alpaca tests negative, what is the probability it does have the disease? What is this type of test result called? For margin of error, we talked about the fact that the population represents the object or persons of interest, and in this case, it's the adults. The sample size is a subset of the population, which represents the actual number, and so we have 575. Now, with a margin of error of 4%, what that means is we have 71 minus 4, and that gives us 67. 71 plus 4 gives us 75. And so our confidence interval is from 67% to 75%.